Hi everyone, I am Dr. Peiris. Today I am going to explain you canonical forms in digital logic design course. In the canonical forms, first I am going to explain you minterms and how to write down the functions using minterms. The second part is to learn maxterms, then how to write the functions using maxterms. So what are the canonical forms? We can write down any Boolean function as a sum of minterms or as a product of maxterms. So if it is in the form of sum of minterms or sum of the product of maxterms, we call that the function is in canonical form. So how do you obtain the minterms? We basically need to look at each combination that produces a 1 in the function. Then we use the minterms with the O symbol. I will explain you that later on how to do that. And similarly, to find the maxterms, we look at the truth table which produces the 0, and then we take all of those combinations and then combine them through the AND gates. So the first one is what are the minterms? So each minterm is obtained from the AND term of all the variables. And if the binary value is 0, we prime the variable. If the binary value is 1, we unprime the variable. So let's say you have a truth table which has 3 inputs A, B, C. So as I have discussed in a previous lecture about the truth tables, if we have 3 inputs, 2 to the third, which is equal to 8, which gives us the number of different combinations. This each row corresponds to a minterm. So how do we write the minterm? So to obtain the minterm, we do the AND between all the variables, and if the binary value is 0, prime the variable. So for example, A, B, C all are zeros, which means we prime them, A prime, B prime, Z prime, and we do the AND between all three. So that's why the first one is written as A prime, B prime, C prime. Similarly, the next one has 0, 0, 1. So 0, 0 we prime the variable, the 1 unprime the variable. So which means this is need to written as A prime, B prime, C. So that is the minterm for the second row. So similarly, we can write the minterm for each and every row. Third one, A prime, B, C prime. The next one, A prime, B, C. Then A, B prime, C prime. A, B prime, C. A, B, C prime. A, B, C. The last one has all ones, which means we don't prime, so it becomes A, B, C. So these are the minterms for each and every row. And here is the designation for the minterms. The small m's are written for the minterms, and then it starts from 0 and then go to 7. So the subscript basically correspond to the equivalent decimal value of each row. So the last row correspond to number 7 in decimal. So that is why this is M7. So similarly, if we take the third one, it corresponds to decimal 2. So this is M2. So we use the small m to denote the minterms. Now let's see how do we use these minterms to write down the functions. So we're going to obtain the canonical form for the following function g using minterms. So these are inputs A, B, C, and the output function is g. So this is the output column for the g. So how do we obtain the canonical form? We first need to find the minterms for each combination of the variables that produces a 1 in the function. And then we take the O between all of those minterms. So what does this mean? You need to look at the function. So we are looking at the function g, and then we go and look for the output 1. So you see that this row has output 1, and then for that row I write the minterm. So this minterm is A prime, B, C. So this is the minterm A prime, B, C. And then I go and look for another ones. So there is another one here. So it's going to be A, B, C prime. The last one is also 1, logic 1. So this minterm is A, B, C. So we found the minterms that produces a 1 in the function. Then we need to combine these Minterms using the O operate. So that is how the first statement is written. So the output G can be written using Minterms. So I have 3 Minterms, and then we need to use the O operation between these 3 terms. So it becomes A prime BC O ABC prime O ABC. So that is the function in terms of input variables. And how do we write the function in terms of the designation, the minterm designation? So this corresponds to M3, M0, M1, M2, M3. So this is M3. So the first term corresponds to M3, and then M4, M5, M6 and M7. So this one M6, the last term corresponds to M7 using the designation. And this is how we basically write in the digital logic classes to write down the functions using the minterms. So this is a summation of minterms. So we use the symbol sum, and then we basically give the designation. So the minterms are at 3, 6 and 7. So we do sum 3, 6, 7, which means we are telling that the function is written using minterms, the summation of minterms, and the minterms are at 3, 6 and 7. So this is how we write the functions using minterms. The next one is Maxterms. The procedure is same as the minterms. The only thing is, instead of O, we use the AND terms when we combine the minterms to obtain the functions. But how do we first write the Maxterms? To find the Maxterms, you must first write down each Maxterm using the O gates. So this is how we write the Maxterms. The binary value is 0, and prime the variable. If the binary value is 1, we prime the variable. So this is basically opposite of the minterms. You do the opposite. If the binary value is 0, unprime the variable. If the binary value is 1, prime the variable. And instead of the AND, we use the O to obtain the Maxterms. So the first one is written as ABC because all are 0, so we don't prime the variable. The next one is AOBOC prime. The third one is AOB prime OC, and then you continue the pattern. The last one becomes A prime OB prime OC prime because all are ones. The binary value is equal to 1, so we prime the variable. Now you see the designation. We use the capital M for the Maxterms. Use the capital M, and again it's going from 0 to 7. Let's see how do we obtain functions using Maxterms. So let's say we have this truth table given. So ABC are inputs and the G is the output. This is the function. So we need to write this function using the Maxterms. So this is written as the product of Maxterms. So for the minterms we use the O gates, but for the Maxterms we use the AND. Now instead of looking at ones, for the Maxterms we must look at zeros. We must look at the zeros on the output column, and then we write down the Maxterm for those. So here is a 0. This is AOBOC. And then third one is also a 0, so this is going to be AOB prime C. This is the fourth one, so this is going to be A prime OBOC. So now we have written all the Maxterms. Now these Maxterms need to be combined with an AND operator. So there are AND between all of these 3 terms. And using the designation, we can write the output G as M0, M2, M4. This is 0, 1, 2, 3, 4. So this is 0, 2 and 4. M0, M2, M4. And as I said before, we use capital M for the Maxterms. Now for the Maxterms, we are basically doing the product of Maxterms here. The product is written using this notation. So this is the notation for the product, and our terms are at 0, 2 and 4. This is how we do the Maxterms. So this is how we do the minterms and the max terms to write down the given functions as in the canonical form. So that's all for today, everyone. So please visit my YouTube channel Dr.Peiris Classroom for more videos of this class as well as for other classes. And don't forget to visit my website drpeirisclassroom.com. You can find the videos for other classes also. Thanks for watching, everyone. I'll meet you again with another video. Bye.